Hey, Algebra 2, it's Miss Iverson. I am here to walk through a level 1 polynomial with you for the 3.6 summative project. So, as you can see, I have written my polynomial right here. The first thing that I'm going to do according to step 1 is determine my end behavior when my polynomial is written in standard form. In order to do that, I need to look at a couple of different things. The first thing I need to look at is my largest exponent. The reason I need to look at my largest exponent is because that tells me what the degree of my polynomial is. And if I know the degree of my polynomial, I can determine if it's even or odd. So looking at my circled exponent of 4, that's my largest exponent, so that would be my degree. 4 is an even number, so this would tell me that my polynomial is even. And I know this, so in this how do you know section, you could write something or state something like the degree of my polynomial is 4. 4 is an even number. All right. So the next thing that I need to determine is if my polynomial is positive or negative. And I do that by looking at my a value. My a value would be the leading coefficient or the coefficient that's attached to the term that's got my largest exponent. So in this case, if I look, I've got no number in front of my x to the 4th. So we assume that there is a 1 there. Now my 1 is positive, meaning that my polynomial function is also positive. So when I state how I know, I can say the a value of my polynomial is positive 1. All right, so knowing if my function is even or odd and positive or negative helps me describe my end behavior. If you remember back to earlier in chapter 3, we talked about end behavior being the same if a polynomial is even and opposite if a polynomial is odd. So in this case, my polynomial is even, which means that my end behavior would go the same direction. And then based on the information that I found, my polynomial is also positive. So that means that my end behavior will point up. So when it asks for me to describe my right end behavior, I can say something along the lines of my right end behavior points up. I can also say the same thing for my left end behavior. Okay, so after we've determined end behavior, we are then going to go to step 2, which is to graph the polynomial. We've given you the tools of Desmos or the TI-84 app for your Chromebook in order to do this. I personally graphed my polynomial in Desmos, which is how I got this lovely graph below. So if I take a look at my graph in Desmos, you can see that this is what it looks like. Oops, I do not want that. But we can also see what my x-intercepts are. So in this case, I only want to take my x-intercepts that are pretty numbers or integers. So they're either positive or negative, but there's no decimals attached to them. Just want the pretty ones. So I'm going to use -1 and +6. So when it asks me to find my integer intercepts, I will write those as -1, 0 and 6, 0. And then on the graph on my paper, I can find those in these locations. The next thing I want to find is the multiplicity of my roots. So I want to determine if they're single or double roots. If you'll remember, a single root crosses through my graph, whereas a double root has a turning point or sort of bounces off my x-axis. So when I'm looking at my roots, I'm looking at my root at -1 and my root at +6. And we can see by my graph that at -1, the line crosses through. So we would call this a single root. And at 6, my line crosses through again, making this a single root as well. Step 3 on this page is to use my x-intercepts to write factors of my equation. When I write my factors, I am going to take the opposite of my x-intercept. So one factor would be x plus 1, and the other factor would be x minus 6. This works for the following reason. If I were to take x plus 1 equals 0 and solve for x, I would subtract 1 from both sides and I would get x equals -1, which is one of my x-intercepts. I could do the same thing for x minus 6, set it equal to 0, and then solve for x, and I would get x equals +6, which is my other x-intercept. So these are my x-intercepts. Might help if I could spell it. Here we go. Let me just start that one over. Intercepts. There we go. All right, so those are my x-intercepts, but these up here are my factors. All right, so as we cruise through this sheet onto page 4, now we have to divide our original polynomial. I am going to divide using the synthetic division, but of course you can divide by whatever works for you. If you are dividing by synthetic division, use your zeros, like use your x-intercepts. So let me make a note of that. Use x-intercepts when doing synthetic division. All right. So if I'm going to use my x-intercepts when doing synthetic division, I am going to use -1 and +6. I am going to start with writing down my x-intercepts so I know which ones I'm using. And then when I start to divide, I'm going to start with my smallest number, which is -1. So I'm going to put -1 in this box. And then I am going to write my coefficients. So of 1, -5, -18, 60, and 72. So we're going to use my coefficients of 1, -5, -18, 60, and 72. Draw this cute little line underneath. And my first step is to drop down my 1. Now I'm going to take 1 times 1, which equals 1. Oh, goodness. Look at me messing up already. We're going to put a -1 here. So I'm going to take -1 times 1, which equals -1. Now I add down my columns. So I have -5 plus -1, which gives me -6. Now I take -1 times -6, which is +6. I add down my columns. So I have -18 plus 6, which gives me -12. I take -1 times -12, which gives me +12. 60 plus 12 gives me 72. And then I take -1 times -72. +72 plus -72 gives me 0. It's really awesome that I got 0 because the 0 represents my remainder. And if my remainder is 0, that means that I did my division correctly. So if I were to sort of rewrite this as a new polynomial, I would rewrite it. So 72 would become my constant. This would become my x. This would be x squared, and this would be x to the third. So if I were to rewrite that, I would rewrite it as x to the third minus 6x squared minus 12x plus 72. My next step in this is to divide again. And the reason that we're dividing again is because I have another 0 or another x-intercept that I can use to divide. So I am going to take the coefficients of my new polynomial to divide again by 6. So if I set this up using synthetic division, I would set it up as 6, and then I would put 1, -6, -12, and 72 right here. Draw my super duper line. And now I can start dividing. So I drop down my 1. I take 6 times 1, which is +6. -6 plus 6 is 0. Now I take 6 times 0, which is 0. -12 plus 0 is -12. And now I take 6 times -12. I get -72. 72 plus -72 equals 0. Again, we got 0 as a remainder, which means we did our division correctly. Woo. Yay! So now I need to start adding back in, like start creating this as a polynomial again. So 12 becomes my constant, 0 is my x, and 1 is my x squared. So if I were to rewrite that, I would write it as x squared plus 0x minus 12. Now, I don't need my 0x because it's just a placeholder, right? Any number times 0 would give me 0, so I don't even need it. So I'm going to rewrite this again as just x squared minus 12. All right, we are almost done. So now that I have x squared minus 12 and I've got the two factors from before, I can rewrite them in step 5. So let's go back and look at what my factors are from step 3. I have factors of x plus 1 and x minus 6. So my polynomial in factored form, I would write x plus 1, x minus 6, and then this is also a factor. So I'd write this as x squared minus 12. Okay, step 6, the final step is I need to find all of the roots or zeros of my function. Now, we already have 2 of them. We found 2 of them back in step 2 when we graphed. We also used them in step 4 when we divided. So 2 of our roots, we can write them right away, is x equals -1 and x equals +6. I have 2 more roots that I need to find, and I'm going to do that by solving for x squared minus 12 equals 0. So in order to find my last 2 roots, I need to take x squared minus 12 equals 0 and solve for x. My first step is going to be adding 12 on both sides. So then I'm left with x squared equals +12. Now I'm going to square root both sides. So I'm left with x equals the square root of 12. I would love to be able to say I am done. However, in this step, we also need to simplify our radical. So I'm going to simplify our radical on the side of the paper in blue. So if I take the square root of 12, I want to know what factors multiply to 12. So I might use factors of 3 and 4. 3 is as small as it can go. So I'm done there. This is the smallest it can go, but 4 has factors of 2 and 2. Now, because I have a pair of 2's, I'm going to lump those together on the outside of my radical symbol. And then because I just have this lonesome little 3, I'm going to put it underneath. So now when I rewrite my roots, or when I go to write that as a root, I can write it as x equals +2 square root of 3 and x equals -2 square root of 3. And then these would be the roots of my polynomial. All right, that completes a level 1 polynomial that you might find on your 3.6 summative project. If you have any questions, please feel free to come see me, Miss Iverson, or go to any of your Algebra 2 teachers. Thanks for watching.